Okay, now we're continuing our discussion of expected value. So we say a businesswoman has two investment possibilities, Project A and Project B. Two ways that she can invest her money. If she invests in Project A, there's a 20% chance that she will lose $10,000. There's a 70% chance that she will break even, means she won't lose and she won't gain anything. And there's a 10% chance that she will make $200,000. So there's a small chance with a big upside. If she invests in Project B, there's a 15% chance she will lose $10,000. There's a 25% chance that she will break even, and a 60% chance she will make $50,000. So a much bigger chance, but not nearly as big an amount that she will win. In which project should she invest? One method of comparison, so one way to compare Project A and Project B, involves comparing the expected values for the two projects. So we have the two projects, A and B, and we have the chances of the various outcomes. Chances of a negative 10,000 outcome, a 0 outcome, and a 200,000 outcome. 0.2, 0.7, 0.1. And Project B, same thing. Chances for this outcome, and this outcome. The chances are 0.15, 0.25, and 0.60. So with this information, we can compute the expected value if she follows Project A, and the expected value if she follows Project B. And what are the expected values going to be? Remember, we take the outcomes of the random variable. So these would be the we'll say let x be the random variable that represents the outcomes of Project A. So the outcomes, the possible values are negative 10,000, 0, and 200,000 for x. And the probabilities associated with those are 0.2, 0.7, 0.1. So what we do is we take the outcome times the probability, the outcome times the probability, the outcome times the probability. And we do the same thing here. So the expected value for Project A is 0.2 times minus 10,000, 0.7 times 0, 0.1 times 200,000, which is what they have here. And for Project B, it's this times this, this times this, and this times this, which is what they have here. And so we get the expected value for Project A is 18,000, and the expected value for Project B is 28,000. So this might mean that she should choose Project B, but it doesn't necessarily mean it. If she really needs 200,000, and if 50,000 is just not going to help her for some reason, like she has to have 200 or something bad will happen, really bad will happen, then maybe still she should go for this one, because this one doesn't even have the chance of getting 200,000. So it's not always the best way to compare, but it's certainly maybe a tool that you can use to compare Project A and Project B. So they say, if her decision is based on expected value comparisons, she will choose Project B, even though the possible profit of 50,000 from this investment is significantly lower than the possible profit of 200,000 if she invests in Project A. Okay, now this is a picture of supposed to be a picture of a roulette wheel, and you can see that there are various numbers and various colors, or there's three colors: white, blue, and gray, and there are various numbers. Now it looks like the highest number is what, 35? No, the highest number is 36. Okay, and so there's a 1, and somewhere there's a 2, and somewhere there's a 3, and it goes up to 36. So there's 36 slots, but that's not right, actually, because there's a 0 and a double 0. So there's actually 38 different slots that the ball can land on. And there's half of the non-white slots are blue, and the other half are gray. I think it's black and red, I'm not sure, but anyway, here it's blue and gray. Okay, so half of the non-white ones are gray and half are blue. And there are 36 numbers plus the 0 and the 0, 0. So actually there's 38. Okay, so let's look at example 6. Consider the game of roulette with the numbers 0 and 0, 0. Those are actually not white, they're green. And 1, 2, 3, 4 up to 36. Half are red and half are black on the wheel. You bet $1 on the number 4. And what happens is, if you win, remember there's 36 chances. If you exclude the 0 and the 0, 0, there are 36 different numbers that you could bet on. So if you win, they will give you $35 plus the $1 that you bet. In other words, you'll get $36 back, but one of those dollars was the dollar that you bet. So your net win is $35. So if you bet on a single number like 4, that you'll get $35 if you win, but if it doesn't occur if the ball doesn't land on a 4, then you'll lose your $1. So if a 4 does not occur, then your loss is $1. What is the expected win for this game? Okay, let's take a look at that one first. So we're going to set up a random variable. We're going to define a random variable to express what are the different outcomes. And by the different outcomes we mean what can happen to you if you play this game where you bet on a single number like a 4. What can happen in terms of your financial outcomes? So what are the two possible financial outcomes? One is that you'll be up $35, so plus 35, and the other is that you'll be down $1. And then the probabilities are what? So what is the chance that you're going to that it's going to land on the 4? We said there are 36 numbers, but then there's also the two 0 and 0, 0. So your chances are actually 1 out of 38. But you notice that they're giving you a payoff basically on as though there were only 36 slots. So they're only giving you $35. If it was so-called a fair game, they would actually give you $37, but they're not doing that. Okay, anyway, so the probability is 1 over 38. Only one position on the wheel, 4, gives a win of $35, so 1 out of 38. And then the probability of losing $1 is 37 over 38. So we have a random variable, and we know the probabilities for each possible outcome of that random variable. So then we can calculate the expected value of your outcome. That is, we can calculate the expected value of x. So what is it? It's 35 times the probability of that, 1 over 38, and it's -1 times its probability, which is this. So your expected outcome is -2 over 38. So it's not 0, and it's not positive, it's negative. Okay, so you should expect to lose this amount of money, which is about 5 cents, each time you play this game. Of course, you never really lose this amount when you play the game one time, but this is over the long run. So if you played it 100 times, you would expect to lose this amount per play, so it would be 100 times this. So 100 times that is $5. So you should expect to lose about $5 if you bet $1 100 times on the roulette wheel on a specific number. Now they also talk about the expected value per dollar bet. Well, we are only betting $1 in this game, so it's just going to be the expected value per dollar bet. It's just going to be the expected value over 1, so it's the same as the expected value was. And then they also define something called the house percentage, which is basically just the negative of the expected value. It's the expected value, or I should say, it's basically just the negative of the expected value per dollar bet. In other words, just the negative of this. So it's going to, and then they multiply by 100. So instead of 0.05, it becomes 5%. Okay, but because they multiply by 100, but they put percent sign, so it's really the same thing. So, but it's the negative of that. So it's the negative expected value per dollar bet. So the house percentage is positive 5%. So this bet favors the house. Okay, now let's see how this works out if you bet $2 on red, not on a single number, but on the entire set of slots that are red. So what is the chance that red occurs? Remember, we said half were blue and half were gray, or half were black and half were red. So what is the chance that red occurs? It's not a half, though, because don't forget there's the 0 and the 0, 0. So there's the 0 and the 0, 0. So what's the chance of red? The chance of red is there are 18, in other words, half of the 36 slots. There are 18 red, so 18 over 38, because the total number of slots is 38. So let's read this. Consider the game of roulette in the previous example. You bet $2 on red. If red occurs, then the net win is $2. So they're giving you $2 if you bet $1. And if black occurs, then your loss is $2. If green occurs, that is the 0, the 0, 0, then your loss is $1. And then they say, what is the expected value of this game? So if these are the outcomes, you can win $2 if it's red. You can lose $2 if it's black, and if green occurs, you can lose $1. So what's the expected value of the game? What is the expected value per dollar bet? And what is the house percentage? Okay, so we're going to do, again, we want to define a random variable that gives us your possible outcomes. So what are your possible outcomes? We just said that you could win $2, you could lose $2, or you could lose $1. So we have the random variable. The values are that it can take are +2, -2, and -1. And the probability of +2, we said, is going to be 18 out of 38, not 18 out of 36. And -2 is also 18 out of 38. And this is 2 out of 38 because there's a 0 and a 0, 0. Those are the green ones. In our picture, they were white, but there's 2 out of 38. Therefore, your expected win is this one times its probability, this one times its probability, this one times its probability. So that's 2 times its probability, -2 times its probability, -1 times its probability. And that turns out to be -2 out of 38. Actually, it's the same number we got before. So your expected value is negative again. The expected value per dollar bet now is that divided by 2, which is this. And the house percentage is this then converted to percentage and multiplied by negative number, so it becomes 2.63%. 2.63%. And finally, example 8, which of the two bets would you rather make, the one in example 6 or the one in example 7? So they say, since the expected loss per dollar bet, the expected loss, we're not talking about winning because neither of them allows us to win on average, the expected loss per dollar bet is less, the loss is less when you play the $2 on the red bet than it is when you play the $1 on the 4 bet. So the expected loss is less, so betting on the red is a better bet. They say, note however that it is possible to lose heavily no matter which game you play, and also that in the long run you should expect to lose in either case. Okay, so let's look at some of these problems here. Find the arithmetic mean of these numbers, so that's straightforward, just calculation of the mean. Find the mean of the following numbers in two ways. So they're asking you the two ways means using the fact that, for example, 14 occurs 3 times and so on. 15 occurs 2 times or 3 times. And so do that calculation versus just do it the straightforward way. Find the mean number, still about the mean here. Let's see, this one, a group of people find the expected value. Okay, so here we have, no, I'm sorry, this is the same kind of thing. So here they also want you to find the mean, but they're giving you frequencies, so you're going to use the frequency approach. Okay, now we come to, instead of just data, which is, these were all questions about data. We just had data. Now we're going to switch to a question about a random variable, which is kind of a different framework than thinking about data. So suppose we have this random variable y, and it can take on these outcomes with these probabilities. So they ask you to find the expectation of y. So remember, all you do is you take this times this, you take the value of y times its probability, plus the next value of y times its probability, and so on. And that's how you solve this. Okay, here they give you a probability function for a random variable. So in that case, we put the values that the random variable can take along the x-axis and the probabilities of those values on the y-axis. So this random variable apparently can take the value 1, 2, 3, 4, and 5 with the probabilities of 0.1, 0.1, 0.3, 0.1, and 0.4. So you just do the same thing. You just multiply the value 1 times its probability, the value 2 times its probability, and so on to calculate the expected value. Again, the same thing here. This random variable can take on 1, 2, 3, 4, 5, 6 different values ranging from here to here with these probabilities like this and this and this, the heights. So again, you just take the values that the random variable can take times its probability, the value times its probability, and sum those up. Okay, the number of accidents on the New Jersey Turnpike during Friday rush hour is 0, 1, 2, 3. So they're saying basically from past data, they've seen that basically during rush hour, the maximum number of accidents is 3. The probabilities the probability that we have no accidents is 93%. The probability that we have one accident is 2%, and so on. This might come from past records. Find the expected number of accidents during the Friday rush hour. So what do you do again? So you define a random variable, which is what? The number of accidents, and the number of, and so this random variable can take on the values 0, 1, 2, and 3 with probabilities like this. So you just multiply this times that times that times that, and that times that. Okay? How many accidents can be expected to occur during Friday rush hours over a 1-year period? So over 52 weeks. So then what do? you've already calculated the expected value from here, and that's for one Friday, rush hour. So over 52 Fridays, it's going to be 52 times that. Okay, let's look at another example. A retailer purchases men's shirts for $3 each and sells them for $5 each. So he purchases them for $3 and sells them for $5. Based on past sales, he estimates the following probabilities for his weekly sales. So there's a chance that he may sell no shirts. He may sell 1, 2, 3, and 4 shirts with these probabilities. If X is the random variable representing the retailer's profit, compute X. So how do you do that? So X is not the number of shirts, right? We could let X be the number of shirts sold and figure out the number of shirts we expect him to sell, and then we could actually answer the question still by if we know he's going to sell 2 shirts, or the expected value of the expected sales is 2 shirts, and the profit is $5. I'm sorry, the revenue is $5 and the cost is 3, so the profit is $2 per shirt, and if he's going to sell 2, of course the profit would be $4. But we could also do it the way they asked us to do it, which is if X is the random variable representing the retailer's profit. So what we need is a table like this one, but for profit instead of for number of shirts. So what if he sells 0 shirts, what's his profit? His profit is 0. Right? He doesn't buy any shirts and he doesn't sell any shirts. His profit will be 0. If he sells 1 shirt, what's the profit associated with 1 shirt? We just said it's $2. If he sells 2 shirts, the profit is 2 times $2, which is $4. If he sells 3 shirts, it's 3 times $2, which is 6. So we could have a table here that's 0, 2, 4, 6, and $8, and that would be the different profits that he could possibly make. And then the probabilities are the same probabilities that we have down here. So we would have 0, 2, 4, 6, 8, and the probability is 0.1, 0.1, 0.3, 0.4, 0.1, and then we just multiply those together and we'll get the same answer that we would have gotten doing it the other way. We'll get the expected value for the profit. Now they ask you, suppose these represent random variables and their probabilities, and they ask you to determine the expected value by inspection, in other words, without calculation. So what do they mean by that? Well, here the probabilities are the same for all of the possible outcomes. So what is the expected value? It's going to be the value right in the middle. It's going to be 3. And here this is a symmetric set of probabilities for these outcomes, and so the expected value again is going to be 3. Okay, so I suggest that you try some of these and also try maybe this type and this type and this type. These are all like the portfolio or the investment that the businesswoman could have done. They're all like that problem. Okay, let's go next to so we've just talked about the expected value of a random variable. Now we're going to talk about something else called the variance of a random variable. Now, you know what the mean is for a data set, and we see the analogy between the mean and the expected value, the mean of a data set and the expected value of a random variable. And now we're going to talk about something We've already talked about the variance of a set of data, or the standard deviation of a set of data. Now we're going to define something very similar for a random variable. It's going to talk about the spread of the random variable. For example, let's see. Don't have any good pictures here, but so here we have a random variable with its probabilities. So we can think that there's a certain spread associated with this. On the other hand, if we had a different random variable where instead of -1, -2, -3, we had probabilities all the way out to maybe -10, and here probabilities all the way out to 10, so that we would say that was more spread out than this one is. So anyway, we're going to talk about that in the next video.